Hey everybody, I hope you're all enjoying the AI Scale Summit sessions. I'm Krishna Gade, I'm the founder CEO of Fiddler.ai. I'm here to talk to you about how important model monitoring is to build trust into AI. The problem that we are trying to solve is that as companies think about operationalizing AI, they're making several mistakes as they go about it. The most recent example that we heard in the news is Equifax, that uses machine learning for predicting credit scores, sent incorrect credit scores to millions of their consumers. A few months ago, we heard the news story of Zillow using AI to predict house prices and how that actually collapsed a lot of their business. A few years ago, Goldman Sachs ran into gender bias issues when they started using machine learning for predicting credit limits. So when you do not do AI wrong, what that actually makes it can make biased decisions for end consumers. It can affect customer trust, especially if your applications are affecting human beings in a real, tangible manner. It can carry this bias that it can affect the society in a deep manner, right? So, for example, if a bank is using machine learning for predicting credit scores, or if a healthcare institution is using machine learning for predicting clinical diagnosis, those models need to be making accurate decisions, and we need to make sure that they're not carrying any inherent bias. There can also be adversarial attacks on machine learning models. These days, you can actually game the models by supplying incorrect data. So here is a panda that I can actually add some noise to the data and make the model predict it as a gibbon with a very high confidence. Or I could see, if convert a stop sign into a speed limit sign, or the other way around. The problem fundamentally that exists is that most of these models that people are building are a black box, which means that we really don't understand how they work. We cannot really monitor their performance at scale. And there are tons of questions when you actually use machine learning and AI these days in the organization. From business teams, from customer support teams, to operations teams, to data science teams, as well as regulatory teams. This is the problem that we are trying to solve at Fiddler. We are a 4-year-old startup that is venture backed, and we are building this platform that enables transparency and visibility into AI so teams can build trust with it. I was working at Meta or slash Facebook a few years ago, working on similar problems on newsfeed ranking and making it more transparent with tools like Why Am I Seeing This that showcased human readable explanations. So the solution that we have built with Fiddler is called Model Performance Management. If you're a developer, if you're probably familiar with DevOps monitoring tools like Datadog that connect to your applications and give you visibility. Or if you're an analyst, you're probably familiar with tools like Tableau that give you insights into how your data is affecting your business. But for a machine learning engineer or a data scientist, they don't have great tools to understand how models work. So with model performance management, what we are trying to do with Fiddler is to accelerate the time to deploy those machine learning models, help you build trusted AI, and improve the predictions over a period of time. So MPM is really a framework to safely operationalize AI or responsibly operationalize your AI. It consists of 4 pillars: model monitoring, which is what I'm going to focus on a lot, explainability, analytics, and fairness. Simply put, MPM is to MLOps what APM tools like Datadog were to DevOps. Let's talk about model monitoring. Fundamentally, what is the problem we're trying to solve here? So, as a data scientist, you prepare the model, you train and test it with your data, you do a model selection by tuning various hyperparameters, and then you validate how the model is performing before you deploy it. And then once you deploy the model to production, you want to monitor that model. How do you monitor those models? What are the human centric design challenges? How would you design a model monitoring system? Let's figure these things out today. So as we built model monitoring at Fiddler, we conducted a lot of user research and asked tons of questions in terms of what kind of applications people were building using machine learning models, why they were needing model monitoring in the first place, what aspects of model monitoring was important to them, and what would be an ideal model monitoring framework. So the domains that we encountered were, it was a broad range of domains that people are using machine learning: advertisement, personalization, financial services, which included fraud detection models, credit lending models, churn prediction models, risk prediction models, especially in insurance, recommendation models for retail, and a variety of different models in consumer technology. So, what are some of the human-centric requirements model monitoring look like? The first thing is, preserving human autonomy and decision making, which means that I want to know insights about my model, so I can get an alert to diagnose it. So I want to see actionable insights and suggestions as a data scientist on how to improve my model. And I want to get meaningful alerts. We are all familiar as developers with alert fatigue, right? We don't want too many alerts, which can cause cognitive overload. So we want a system that can give meaningful alerts at an appropriate point of time so we know what's wrong with the model. Ability to do diagnosis and root cause analysis is very important. So your model may be performing well on the overall population, but there might be sub slices or subpopulations in your data that the model is having an unexpected behavior. Being able to discover them is going to be very important. Gaining insight on model errors so you know when to retrain it, so that you know what are the problems that you have within your training data that can help you fix that model. And allowing abstractions such as feature level monitoring, so I can monitor feature level quality issues, or prediction level monitoring, performance level monitoring. Model monitoring is also important from a risk management perspective. Fiddler works with a lot of financial services organizations today that are mandated by regulatory guidelines to monitor the models, to manage the risks around the models, to govern those models. It's very important for those teams to create reports around how a model is working and share it with their risk managers and auditors and external regulators. So, being able to build a monitoring system that ensures privacy and confidentiality of these assets and helps the teams to understand how the models are working in one centralized place is actually very, very important. What are some of the challenges for model monitoring? What should be monitored? What is model monitoring at the end of the day? Are you monitoring the data that gets fed into the model? Are you monitoring the outcomes of the model? Are you monitoring the business impact related to the model? How should a model monitoring system be designed such that it interacts with the model? What are the technical dependencies with the model? How do you protect the privacy of users? And you may have an entire set of training data that you may not want to divulge. And it might be an intellectual property for a company. And then what are some of the things that you want to monitor after deploying a monitoring system? Is it actually reliable in terms of providing drift metrics for mine? How immediate you want to see these issues? How what's the latency of finding these issues? How do you debug these model monitoring systems? When they go wrong, especially if you're deploying a system in a third party environment, such as a virtual private cloud or on-premise. So let's say if we have a monitoring system, what will it give me? What's the business value? How will it help me, get more insights? How will it help me, get, do some action with those insights so you can actually improve the model? So let's look at some of the key aspects of drift that one needs to monitor when they deploy models to production. So here is a model that is classifying between the yellow circles and the blue circles. What it is essentially doing is it's learning a decision boundary that separates the yellow circles and blue circles nicely. Now, when you deploy that model to production, you may encounter what is called concept drift. What that means is that suddenly the relationships between yellow and blue and the way the model was trained have changed. And so now you may have to retrain the model to account for these changes. And I'll talk about some examples what concept drift means. And the other drift is data drift. Now, in this case, the data changes, the relationships may not really change. So in this case, the decision boundary has changed, and essentially now you have to figure out if your data pipeline is spitting out bad data for you, or something has changed in your inputs that you're collecting that you need to account for. The other aspect of it is the label drift. And so essentially in data drift, you have two aspects. One is label drift, where you want to see if the output is shifting over a period of time, or if your features are shifting over a period of time. And then there can be virtual drift, where the data changes, but the boundary still works. So you may not really have to do much here. In this case, so the real problem is to detect if it's actually a real data drift versus a virtual data drift. So what's an example of a concept drift? Let's say you've trained a loan application model. And an income level that was considered credit worthy before is now considered riskier. This typically happens in recession, right? So now let's say the economy is going into recession, and now whatever models that you may have trained before the recession may not be good enough because the risk has increased to issue loans now. What's label drift? Label drift is where a large portion of the creditworthy applications are now starting to show up. Let's say now you are, you're now you're a lending company. You started with a certain type of loan applications, and now you started selling your lending product into a wealthy area, or a different country, where suddenly proportion of your creditworthy applications suddenly increased, and you have to account for that. Let's say in the third one is a feature drift. In this case, you know, a particular feature that's affecting the model, let's say salary of the applicants, that has shifted. It can, let's say you have trained the model with features that are distributed in a certain range. Let's say you've trained the model with salaries between $100,000 to $200,000. But when you deploy a model in a different segment, in a different population segment, that income may increase or decrease, and that can affect the model's performance. So what triggers model drift, right? So that is it a real change in the sense that you launched a new product in the market where you're seeing new behavior, new types of credit applications show up, new income levels show up. That actually is a real change. Or a competitor has launched a new service, so now you have seen a concept drift, or Fed has increased interest rates. That has made the loan applications more riskier. So that's also a concept change that may require a new model. And then there can be data integrity issues. You can have data drift because of data pipelines, where the data pipeline that is serving your model, the feature data, that may have changed. You may have an application that is sending you the data that your model is using to train. So user activity data on the application, or like the server logs that you're collecting, all of them can be used to compute those features. So for example, let's say I have a data pipeline that computes debt to income values, and now I have swapped the debt to income values with age. That's actually a data pipeline error that could cause data drift. And incorrect data could enter at the source. I already talked about how logging incorrect data can affect your models. So how would you detect these drift issues? You need performance monitoring. Here we would use supervised learning techniques to detect if there was a performance issue. And you need drift monitoring, which can rely on the unsupervised learning issues. So let's look at performance monitoring. So what is performance monitoring at the end of the day? Here is a model that's predicting churn probability. And over time, you can see how the model is doing, and we are tracking drift in the probability of churn. And for a long time, it was very close to zero. And then on June 14th, it increased to 0.21, right? This may be a time where the system might alert for you. In this case, you are monitoring performance metrics that are giving you metrics around AUC, metrics around false positive rates, accuracy. And so this is basically where you're using ground truth to measure the model's performance. The other one is drift monitoring, where you're trying to measure statistical distributions, shifts between training setups and production setups. You may have a situation where a feature that has a different distribution in the training setup and the production setup. Here you would use a number of distribution shift metrics like PSI, like KL divergence, like Jensen-Shannon divergence, or the KS test, that can give you an idea of how the model is doing in terms of catching into how the data distributions are shifting. There are a number of unsupervised learning methods as well that you could apply to detect if the models are drifting. Getting to the root cause is very important, right? So when you actually find drift or data integrity, you want to know what's going on and why that is happening. So data errors are the primary reasons why model performance degrades. A lot of the times our customers at Fiddler, what they find is missing values coming through their data pipelines, range mismatches, type mismatches, schema mismatches. They all look like real drift, but they're actually data pipeline issues, that human developer issues that can actually degrade performance. Changes in business, new catalog products, pricing changes. If you're using If you're selling your product at a different price than that, how that affects your models. Broken data pipelines. So the drift analytics, what it helps you is it helps you connect, the model's drift, and then to the individual, and sort of attribute it to the features, the inputs that are actually powering the model performance. So you can say that, okay, my model is drifting, but what are the constituent features that are responsible for this drift? So this mechanism of attributing prediction drift to the model drift is called prediction drift impact, where it's a score that signifies what is the impact of a particular feature on the model performance. So then now you can remediate this thing, right? So how do you remediate these model performance issues? You can update the pipeline, you can retrain the model, or you can refresh the data. Most of the time, you may be having a training data set issue that you may refresh the data and the problem goes away. You can do like model management, where you can do like model ensemble balancing, where you can have multiple sub models that you want to create for different subsegments of the data if one particular model is not working for you, and then combine them together. So now that we have learned about the challenges of building model monitoring systems, the use cases, how model monitoring can help ML teams, let's actually look at what we have done with the Fiddler product and how we are helping ML teams here. The core mission of Fiddler is to help organizations build responsible AI. What does that mean? It means that teams, when they actually are productionizing machine learning models, they can do a lot of analysis and monitoring of the data that is going into the models, the data that's coming out of the models, check how the models are performing, assess fairness capabilities of it, create reports around how the models are being consumed within their organization, and then being able to remediate those models so that they can fix model performance issues. We believe that model performance monitoring is the cornerstone to build trustworthy and responsible AI. And the way it comes into light is basically being able to build a system that can ingest data from a variety of sources. These days, machine learning teams use a variety of data infrastructure to store their feature data and log data. It could be Amazon S3 buckets or Hadoop systems or Snowflake systems. Fiddler is able to consume data from a variety of these data sources and then integrate it with a variety of modeling frameworks, from scikit-learn to TensorFlow to PyTorch, to bring together a comprehensive solution that can help you monitor the model's performance, explain the model for both locally and globally, and being able to root cause analyze performance issues. Here is a visualization of all the dashboards that Fiddler illuminates once you connect your models and data pipelines to it. It provides you a single pane of glass experience, a cockpit view of all your models and their performance, where you can monitor them at scale, monitor and get alerts when things break, and then diagnose the model performance using explainability. These dashboards then can then be shared by the data teams to various different stakeholders, to business stakeholders, to legal compliance stakeholders. And that's what excites us to continue to push this field and continue to do research to advance the state of model monitoring and explainability and work with some great partners. Thank you so much for having me in this talk.